and that does have an effect for database availability groups, and you'll want to understand what that is. And then we'll talk about the new process that you need to do in Exchange 2013 to take a DAG member and put it into what we call maintenance mode so that you can do updates and other things like that. The process to do that is very, very different from what we had in 2010 with the maintenance scripts that we had, so we'll get into that. So let's start with the DAG architecture, and I want everybody to understand that we're focusing on the components that comprise the database availability group, which includes obviously mailbox database copies and ancillary technologies like dynamic lag replay, auto reseed, and so forth. So the primary component of the DAG is called the replication service. Its long name is the Microsoft Exchange Replication Service. MS Exchange REPL is its short name, and the executable, as you can see from its short name, MS Exchange REPL.exe, is an unmanaged code, so it's written in C#. And it is the primary workhorse for the continuous replication pipeline and for the database availability group. It contains several components. In fact, there's about 16 different components in there. And we're going to talk about what they are. But it does everything from providing the administrative interface that admins use to manage a DAG, to providing RPC endpoints for tasks, to managing database state and status, to reporting that, to storing that, to making failover decisions, et cetera, et cetera. So it is the primary component. Now, it's not new in Exchange 2013. We actually introduced this service in Exchange 2007, but it has undergone some very significant changes since then. We've added a lot more functionality. We have changed the continuous replication mode that we use. Back in 2007, we were SMB-based. In 2010 and 2013, we are raw TCP/IP-based, where we just control the socket. And in fact, that's one of the functions that the replication service does. Now, internally, in places in the code and in our own specs and conversations, we actually refer to this service as generally the replay service. So if you ever see obscure event logs, or if you happen to do some extended tracing of the replication service, you'll see references to the replay service. So don't be confused. It's the one and the same service. It's just its official name is the replication service. So if you hear us talking about or you see references to replay service, this is the service that we're talking about. So let's talk about some of the functions that it does. Some of the functions are user-related. Some are internal continuous replication-related. So for instance, the Active Directory lookup. Those are lookups so that Active Manager can figure out what database availability group it's a member of, what server it's running on, what the other servers are part of that DAG, and so forth. And then there's an Active Manager client component that exists in the client access server, and that will also do Active Directory and Active Manager lookups against this particular component inside the replication service. There's a copy status lookup. Anytime I issue a task that does get mailbox database copy status, or when I bring up the Exchange Admin Center and I'm viewing the copy status for the content index or for a database, that's the interface that we're using in there. So that comes from the replication service as well. The Replay Core Manager, that is there to manage the entire replication pipeline. So it's there to make sure that logs, the proper logs are being pulled, that they're being inspected properly, that they are placed in the proper directories, and that the replication is succeeding and operating as it should normally. The Seeding and Auto Reseed Manager, as their names imply, these are the components inside the replication service that are there to manage initial database seeds. And then if you're using the new Auto Reseed technology that we have in Exchange 2013, there's a separate component that will manage that. And the auto reseed will work with another component inside the replication service called the disk reclaimer service. That is the component inside the replication service that is responsible for grabbing an available spare disk so that it can be replaced with a failed disk, or that it can replace a failed disk rather, and auto reseed can then do its thing by bringing up a fresh database copy, or in the case of multiple databases per volume, multiple database copies. The Replay RPC server wrapper, that is there to take any RPC communication and basically wrap it up into the form that our replication server, the underlying core manager process in the replication service, can understand and manipulate and pass around to other DAG members if necessary. The remote data provider wrapper, that is to go out and remotely query other DAG members and find out what information they have to make sure that everybody is consistently on the same page. The VSS writers, they are to manage backups. And then, of course, the biggest component that we have is the Active Manager component. Active Manager, as we've described before, is kind of like the brain of high availability. It is there responsible for tracking everything, and it's also responsible for making decisions that affect failover at both the database and the server level as well. Some of the other interesting things, the TPR API manager, TPR stands for third-party replication. We still do have a third-party replication API inside the database availability group. There is one vendor that does make a product that does use that API, but I have yet to encounter any customers that are using that. Most customers seem pretty happy with the default continuous replication that we include. And then there's other server locators and health state trackers that, as their name implies, do those kinds of things. They find out where the servers are located. They interface with the cluster service to find out if the servers are up and down. And they also track the state of databases and their logs, as I'll show you in some examples in a bit. Now, in CU2, we began the process of offloading some of the functionality out of the replication service and into a brand new service that we introduced called the DAG Management Service, or Microsoft Exchange DAG Management Service. As you can tell from its short name, it is also unmanaged code, so it's also written in C++. And its lot in life is to basically start taking over functionality from the replication service. The replication service itself is getting a little too big in terms of the functionality that it's doing. And all it takes is one problem in one of those functions to crash that service and cause all the other things to stop working. So we wanted to make sure that we had this functionality spread across in a manner that allowed it to be distributed without adding excess load to the system, but at the same way gave us greater resilience for the replication service. Right now, there's just 4 components that we've forklifted over, and 3 of those 4 are actually in an inactive state. They don't work. They're just there plumbed to get ready for the process of moving more functionality over. So right now, the only one that we're doing now is the monitoring functionality. That is the only component inside the DAG management service that is operating and actually doing work. And it's there taking over the monitoring function from the replication service. So as an example, one of the types of monitoring things that it looks for what we call a single copy condition. That would be when you've got replicated databases, but you're down to just one copy of that database. That's a very bad state to be in, particularly if you've deployed on a JBOD environment, because you won't have RAID protection. Therefore, a disk failure will take out your last database copy. So that's a very critical type of state for an administrator to be aware of. And so that's the type of functions that the DAG management service is doing. Again, you should expect more functions to come over as we continue to refactor the service. Now, as the DAG management service is doing its work, it actually simulates the replication service. We literally just moved the code over into a new process and gave it a new name. That's all that we've done this far. So as it does its event logging and as it does its reporting and so forth, it reports in the event log as if it were the replication service still, because that's how it's currently coded to do that. Eventually, we may change the event source to, say, DAG management, but for right now, it's writing exactly to the same places that the replication service wrote to in CU1 and RTM, and it's using the same events and the same source of MS Exchange REPL. Some of the other things that we expect to move over there, that auto-reseed functionality and the disk reclaimer, and then there's also the dynamic lag playdown that I talked about as well. That functionality will get moved into the DAG management service eventually. And I can't speak too much about that last bullet item because it is future stuff and we typically don't talk about this. But those of you with a keen eye, if you run commandlets like set database availability group, and I love when I say I can't talk about stuff, all the cameras come up and start taking pictures of the things I can't talk about. But it's on the slide and you'll get this and it'll be in the recording. But those of you with a keen eye will recognize that if you run set database availability group, you will see many DAG properties that begin with the term auto DAG. In fact, there are 3 of them that we use as part of the auto reseed technology that you have to configure. And again, if you go to the previous version of this session and the recordings, you'll see what those properties are. And of course, they're documented in TechEd as well. But you'll see that there's many, many more than just 3 of those properties there. And so you can sort of guess the kind of work that we're planning on doing based on things like the property names and the type of values that they might be able to provide for you. Now, of course, the database availability group is the Exchange application layer that lives on top of a Windows failover cluster. So the cluster, from an Exchange DAG perspective, is a core component of the DAG. We cannot operate a DAG without it. We can certainly operate mailbox servers without the cluster, standalone mailbox servers, but we can't operate a DAG without a cluster. One other thing worth mentioning, in fact, let me just back up real quick. Yes, there's a new DAG management service, but even on standalone mailbox servers, there is the replication service. That replication service, even if that mailbox server is not in a DAG, is a required service for all mailbox servers, because again, that's where Active Manager lives. And in Exchange 2010, 2013, Active Manager controls whether a database gets mounted or not. Yes, the store still does the mount operation, but it will only do so if Active Manager asks it to. And Active Manager can only do that if that service is running. So even though we've talked about the replication service in the context of a DAG, it is required for even standalone mailbox servers as well. Okay, so the cluster service, that is also very mature and very proven technology. That was first introduced way back in NT Enterprise Edition in 1997. And it's also unmanaged code. It's just called the cluster service, or clus SVC, or clus SVC.exe. And Exchange is basically a consumer of clustering technologies. We are not what we would traditionally consider to be a cluster-aware application, because we do not have any Exchange resources that live in or are managed by the cluster. We just consume cluster technologies. Okay, so what technologies do we use? Well, obviously, we use the concept of quorum. We use that for availability purposes, and the concept of quorum has actually changed quite a bit in Windows 2012, and we'll talk about that when we get to dynamic quorum. We also use it for the membership and node management. We use it to take a bunch of servers and group them together in a group that forms a boundary for replication. And we use the node management APIs to find out from the cluster when one of these servers goes down and comes back up. So that's where we get that information from. We also use networks and heartbeating. So the cluster networks, when we deploy a mailbox server onto a DAG, the networks are interrogated by the cluster service, and the cluster passes that information to the DAG, and every network that the cluster finds gets turned into a DAG network. So if you're doing separate networks for a MAPI and replication network, when you add that server to the DAG, the cluster will recognize two networks and give you two separate DAG networks as a result of that. Now, we also use it for heartbeating. We use it because this is the mechanism that tells us whether a server is actually up or down, or whether a network interface is responding or not. Now, one thing you need to be aware of is that all networks are heartbeated in a cluster. So how many of you have heard of a heartbeat network in a Windows failover cluster? Okay, so forget that, because there is no such thing. And there never has been, because all networks in a Windows failover cluster get heartbeated. There's no such thing as a heartbeat network. They all get heartbeated. Okay? And we use those heartbeats to find out whether or not its node is responding, and if its network interface is responding. And if the node doesn't respond, the cluster evicts it and basically throws it out temporarily. And does some interesting things with its votes now in 2012, which we'll talk about. And then we use the cluster registry. The cluster registry, sometimes known as the cluster database, is where we store tons of information about all of your databases, all of the logs, the content index state, whether or not the admin has done things to the database, and so forth, as you'll see in a moment. We store that in the cluster registry because any writes that are made to that database are instantaneously replicated to all the other members in the DAG. That is the way we communicate information across all DAG members very quickly about database information. And we need a very quick mechanism because we have failover that can occur very quickly. The database state can change, and the database location can change very, very rapidly. So we need a fast place to store it. We would never be able to store that, for example, in Active Directory, because we would be completely bound by Active Directory latency in the transfer of that information. So we store that in the cluster database, and it gets replicated instantly to all members of that cluster. Now, why do we use quorum? Well, we use quorum as the determining mechanism to tell us whether or not we have a sufficient number of servers available to be able to mount databases. The rules are simply this. If you have quorum, and if the DAG member can reach what we call auto-mount consensus, then it has the permission to mount databases. If it can't reach auto-mount consensus, or more importantly, if the solution does not have quorum, then everything terminates. Cluster service terminates, the replication service does not mount databases, and all service is down for that DAG. Now, quorum is based on votes, not membership. And this is, again, a slight nuance difference from what we had previously. Because now you have the ability to manipulate votes. The voting can be rigged. You can take votes away from DAG members, from cluster members. And that has the ability of increasing the complexity of your deployment, simply because Exchange has no awareness of votes. Exchange uses only one of two quorum models. It will use the node majority quorum model if you have an odd number of DAG members, and it will use the node and file share witness majority model if you have an even number of DAG members. And all Exchange knows is the server count for membership. It doesn't know anything about whether that server actually has a vote or not. So that could be an interesting and lengthy discussion if you decide to go down the path of manipulating votes by dynamically taking them away. If you do go down that path, that's going to require you to manually manage the quorum model yourself. We've actually done a fair amount of work in Exchange to have the cluster largely completely abstracted away from the Exchange administrator. So the admin doesn't really need to manage quorum at all as long as you stick to the default settings. But if you start taking away votes, then Exchange will not be able to manage the quorum properly because it won't know the calculation of quorum, which again is based on a majority of votes. So keep that in mind if you do that. Now, the cluster registry. Active Manager stores all of the database and server information that it has about the DAG, including health status information, inside this cluster registry. And on a standalone machine, we store it in a separate hive in the registry, but this is in the cluster registry. And then those changes are made, are replicated to all the DAG members as soon as they are written. So every DAG member has a uniform and consistent view, if you will, of what the health and status of servers are. So no matter what server you'll interface with for your management tasks, you'll always get the same information back because they're querying that out of the registry here. We also store information as part of our best copy and server selection as well. So this is where we're now tracking certain information that we didn't previously track in prior versions. For example, there's a setting that you can configure called maximum active databases. That setting gets set in Active Directory, but it's also now tracked in the cluster database so that we can use that as part of the best copy selection process so that if one of the servers that might be a candidate has already reached the maximum number of databases, we can simply ignore it as part of the evaluation algorithm. So this is what one of the entries looks like here. Let me go ahead and actually forgot to start zooming again. Got to remember to do that. So let me pull up Zoom It so I can zoom in on some of this stuff. So this is what one of the entries looks like right here. You can see it's this yellow entry, is entry exists, true, and then there's the name of the server and all this information that is actually wrapped for readability here. So some of the things that are on here are going to be pretty self-evident as to what they are. Obviously, the active server is simply the server that currently hosts the active copy of the database. The last mount server is typically always going to be that same server because it's the server on which we last successfully mounted that database. And we've got last mounted time in there to show you the time at which we last successfully mounted the database. There's the mount status there that'll either say mounted or dismounted. And that could be dismounted because of an admin reason. So we'll also tag whether or not it's admin dismounted. One of the things that I mentioned during the Q&A of the session on sizing last night, I made reference to the fact that now in Exchange 2013, when you add or remove databases or add or remove database copies, you need to restart the store service on that server so that we can recalculate the static amount of cache we give to those databases. And that store service restart is a manual admin action. Anytime an administrator is taking those kinds of actions, restarting a service, stopping a service, or going in and dismounting a database, those actions will be honored by Active Manager. Active Manager will not come in and switch over or fail over a database because an admin gracefully dismounted it. So we will honor that stuff, and if we see that, we'll tag it in the cluster registry so that Active Manager won't touch it. Now, what's interesting about that is, yes, Active Manager won't touch it, but we have this new technology called Managed Availability. And for certain actions that you will do, for example, stopping services, Managed Availability has a list of critical services, one of them being the replication service. If you do stop that service, managed availability will come back and start it up because it is a required service for running. So do keep that in mind. If you actually do need to stop the service for a lengthy period of time, you'll probably need to put the server into maintenance mode so that managed availability doesn't come back and restart it for you. And again, we'll talk about maintenance mode at the end of it. And then the last piece of information is the automatic actions allowed? So for instance, is the database blocked from automatic activation? That we also track in there so that as the database moves to another server, will it get automatically mounted or not? Some of the other information we store in there, not just database-related information, but log-related information, as you can see here. So here what we're showing is basically the last log. These entries right here, this is the GUID of the database itself, and we keep the last log value here in a decimal value. So if you were to take that, put it into a program or calculator, you could convert it into hex, and that will show you the hex number of the log, whose file name you can find in the file system at that point. So this is how we keep track of what logs the passive copies have received and what logs still need to be sent by the active copy. If the passive copy does have logs that are outstanding that it still needs, it will request that through that raw TCP socket that we control, and then the active copy will push those log files over through that channel. Now let's talk about the Crimson channel. This is another Windows component that is required for normal and regular operations of Exchange. The Crimson channel is simply the name for an area inside the Windows Event Viewer, the Applications and Services area, where applications can log their own events for whatever purposes they need, but they can also be consumers of those events as well. So it's a communication channel that can be used by different components within an application to communicate information between them. And in fact, we use it extensively in Exchange for that purpose. So one of the examples is we have these self-recovery mechanisms where if we encounter certain extensible storage engine errors, the system has the ability to self-recover from that by taking some sort of recovery mechanism. Sometimes it includes bug checking or blue screening the box to force a server failover. So an example of that is I have some sort of underlying ESE error. When that error happens, it gets logged into the Crimson channel. Active Manager regularly monitors the Crimson channel. It's an event subscriber. So as soon as that event gets logged into the Crimson channel, Active Manager sees that and invokes that recovery action that I just mentioned. So obviously, if the Crimson channel is non-operational, Exchange cannot do its job. And we actually also have in Exchange 2013 a recovery mechanism for that as well. It's also in Exchange 2010. If, for example, an Exchange server is unable to write to or read from that Crimson channel for a period of 30 seconds or more, it will forcibly reboot that server to trigger a server failover in hopes of resolving that problem. Maybe it won't resolve the problem. Maybe that event is, or the event log itself is corrupt and needs to be thrown away and replaced, but at least it will try to establish functionality. And of course, the server reboot will trigger a server failover, so even if it doesn't work, it will not come up with any active databases on it, so it will be a non-client impacting outage. So we have multiple channels. Some of these are really just for the developers only. I mean, you're free to go in there and see what gets logged, but you will not be able to interpret the events without hooking up to our symbols in our code base. But feel free to look at the kind of stuff that we do. A lot of it is just tag information or H results or error codes or that kind of information. But there's also human readable information in some of the operational event logs that we have, and certainly in some of the managed availability logs that we have as well. In fact, I would strongly recommend that you get to know the managed availability event logs quite well, because those are going to be your source to find out what actually managed availability is doing. And if you come to the tips and tricks session tomorrow, I'm going to show you exactly how to do those kinds of things in that log as well. So some of the things that we have that are kind of interesting for us, active monitoring. Active monitoring is the other internal name that we have for managed availability. Don't ask me why. We seem to have one external name for things and then a different internal name for other things. We do that a lot, and so it can cause confusion sometimes. But when you see active monitoring, it's really just another name for managed availability. So there's a couple managed availability areas. But from the DAG perspective, it's the high availability area and the troubleshooters that are going to be most interesting for you. And within those sub-channels, it's going to be the operational channel that will be most interesting for you as well. So here's an example. This is just a screenshot to show you what it looks like here. So again, it's in Event Viewer under Applications and Services Logs, and then you'll see this entry for Microsoft, and an entry for Exchange, and an entry for Active Monitoring, and all the other ones that I had listed there. It's really just the active monitoring and the high availability one and the troubleshooters one that will be germane from a pure DAG perspective. The active monitoring and the managed availability ones will be great for when you're going through managed availability troubleshooting or diagnostics. All right, let's talk about witness server placement. And I just threw this slide in this morning because I wanted to make sure that everybody understands what we use a witness server for and why we need one for DAGs. So the witness server is just some server in your organization, some Windows server that is not a member of the DAG, that is there for the sole purpose of providing this extra vote in the case a tie-breaking vote is needed. It's only used for DAGs that have an even number of members in it, but it is a required configuration element for all DAGs. So all DAGs will have a witness server configured for them, but only DAGs with an even number of members will actually use the witness server. Because obviously, if you have an odd number of members, you don't need a tiebreaker. You can't have ties. When you have an even number of members, you have to do something to figure out, well, what if 2 say this and 2 say that? Who do we believe? That's what the witness server is there to do. And it's a very lightly used file share, so you don't go and get a dedicated server. Every customer already has candidates for witness servers in your organization. For example, you cannot have DAG members that are directory servers. Therefore, all of your directory servers are outside of your DAG. So even if you don't have any other servers, all you have is directory servers and Exchange servers and a DAG, you still can use your directory servers as your witness servers. It's just a very lightly used file share that actually only comes into play when that witness server vote is needed to maintain quorum. If the witness vote is not needed to maintain quorum, then the witness server is just barely used at all. There's just a little is-alive ping that the cluster does to make sure the file share is still readable, but that's it. That's all it's used for. Now, in terms of where that server should be, our guidance has changed quite a bit over Exchange 2010. In Exchange 2010, it was fairly simple guidance. Find a hub transport server inside the Active Directory site where your DAG is located that wasn't a member of that DAG. And in fact, our code, we actually have our code in 2010 and 2013 for that matter, programmatically designed to do that. Although in 2013, since there is no hub, it's looking for CAS, a CAS only. And if we found that server, we would go ahead and just start using it as your witness server. The only reason we wanted you to use a hub server or some other Exchange server is because we want the witness server to still be within the visibility and under the radar of the Exchange administrator. Because if you do need that witness for quorum, but you aren't aware of its availability, the last thing you want to do is go shut down a node to do maintenance on it, because that could mean the difference between maintaining and losing quorum. So you don't want to cause an outage. So we wanted the witness server to be within the purview of the Exchange administrator. But really, you could use any Windows server that you have in your organization for this. Now, if your DAG was extended to multiple data centers, we always recommended that your witness server only be placed in the primary data center or the data center where you wanted to retain the majority of votes, where you wanted quorum to be maintained in the event of a WAN failure. In 2013, it's a bit more complicated because of the architectural changes that we made. It really now gives you some new options that were not available before. And so that would be new options like a third location, like a branch office, for example, or if you have the luxury of a third physical data center, for example, you now can put the witness server inside a third location. And as long as that third location has network connectivity that is isolated from network failures that could affect the other 2 data centers, you could achieve automatic site failover for your database availability group. And largely for the rest of your services as well, since again, the mailbox role in 2013 now includes all the other roles as well, except for the CAS proxy. But we don't need to fail over the CAS namespace or the CAS proxy just because the DAG and everything else is moved over. So you do get automatic failover from a DAG and from a client experience perspective. So ultimately, where you place your DAG's witness server will be based on your DAG configuration, your business requirements, and the types of failures that you need to sustain. So obviously, if you have a single DAG and a single data center, that's a no-brainer. Your witness server is going to be in that data center. If you have a single DAG extended across 2 data centers, you're going to put the witness server either in a third location, if you have one available, or in the data center where you want the majority of votes to be. If you have a DAG extended to 3 or more data centers, gets to be a bit more complicated, but it is something that you can do, then you would want to go ahead and, again, place that witness server in the data center where you want the majority of votes to be in the event of a WAN failure. You're going to have to make a decision one way or the other where that majority is going to live. All right. Now, if you do have that third location, you can get that automatic site resilience, but it's very important that whatever third location you use, its networking infrastructure has to be isolated from failures that could affect the other 2 data centers. So if you're using sort of a hub and spoke mechanism where you have to go through a hub data center so that other data centers can communicate, then you might have a challenge implementing this configuration. But if you've got pure isolation, in fact, even better, separate points of ingress and egress to and from the internet for that third location, or separate leased lines or separate whatever network connectivity, then you can have a pretty good experience and get that automatic site failure. Now, again, for all DAGs, though, the witness server should be on the Exchange admin's radar because you never know what failures are going to happen and when that witness server might be needed to maintain quorum. So wherever you place it, again, it doesn't need to be on an Exchange server, but the Exchange administrator should be aware of change management activities that affect that server. So if someone's going to be taking that server down for maintenance, the DAG admin needs to know about that because that server might be needed to keep that DAG up and running at that time. Now, back a few months ago at TechEd North America, we announced that we were investigating the possibility of using Windows Azure as a third location for a witness server for customers that don't already have their own 3 or more locations. Unfortunately, that investigation ran into a dead end. What it boils down to is Azure simply does not have the required networking infrastructure in order for us to use this in a multi-site environment. You certainly could configure it in such a way that you could use it as a cloud-based witness in a single site DAG deployment, but there's actually 0 benefits to doing that, and there's no reason that you would spin up a VM simply for that purpose. So we're still investigating it, and as soon as the Azure folks introduce that extra networking support that we need, we will jump on this and test and validate and try to get it out as a supported configuration option for you as soon as possible. And you can read all the details at that blog that I posted on there about this as well. But we are staying on top of this, and the Azure folks have an official request from Exchange for that underlying network support, and once they have implemented it, then we can move forward with this. But for right now, unfortunately, there are no IaaS providers that are supported for use for your witness server right now. So if that third location has to be your own location right now. All right, let's talk about dynamic quorum. How many of you have heard of dynamic quorum already? Okay, just a few hands. Okay, so dynamic quorum is a brand new feature in Windows Server 2012 and later, so it'll be in the next version and so forth. And it changes the way we calculate the number of votes that are available in the cluster. Typically, historically, I mean, when a node went down, it didn't lose its vote, it kept its vote. With dynamic quorum, that changes. When a node goes down, its vote is taken away. And if you have a sequential series of downs, which could be failures or graceful shutdowns, the votes will gracefully get taken away, and the cluster will dynamically recalculate the number of votes that are required for quorum by removing those taken away votes from that calculation. So basically, as a node goes down, the quorum requirements shrink, as long as the system can maintain quorum again. If it can maintain quorum, the quorum requirement shrinks, so if you have another outage, the same process will happen again. It will recalculate quorum, verify that it has enough to stay up, and if it does, it will reduce the number of votes required to maintain quorum. And this is enabled for all clusters by default. It's on all Windows Server 2012 clusters, which means if you've deployed on Windows Server 2012, it's on right now, operating in your DAG. Now, This means that the cluster now is dynamically managing the votes based on the individual node's state. So again, as I mentioned, if the node goes down, its vote is gracefully taken away. When it comes back up and successfully rejoins the cluster, its vote is given back to it and it's reintegrated into it. This is different from the administrator manually manipulating votes by removing them themselves. Obviously, if the administrator goes in and removes a vote from a DAG member, dynamic quorum does not come back in and give that vote back as that machine comes back up. So dynamic quorum will only remove votes from systems that are not already being managed manually by an administrator. What this does is it now enables the cluster to maintain availability in some scenarios where previously it wasn't able to. Okay, and there's very few scenarios. But it now is possible in this model for a very large cluster. Windows Server 2012 clusters can go up to 64 nodes. Even though that's the case, DAGs can still only be 16 members or smaller. But even if, well, let's forget about the DAG for a minute. Let's say you had a 64-member cluster. You could actually encounter a failure scenario or gracefully shut them down one after the other until 63 of them are down. You will still be left with a viable running cluster with one node. We call that a last man standing scenario. But that is now a new and possible scenario with Windows Server 2012 and failover clusters. Now, I want to be super clear about that. Don't get caught up in wanting this last man standing scenario. It's not really useful from an Exchange or DAG perspective, and it presupposes that that last man standing has enough resources to service the load of the entire now gone database availability group. So generally, if you've got a 4-member DAG or a 6-member DAG, you're not going to lose 3 members or 5 members and still have that one surviving member still be able to carry the entire load. That's probably not in your design plans. So the other thing about dynamic quorum is it's not there to prevent against simultaneous failures. So in the case of like a WAN failure where multiple nodes go down, or in the case of a rack failure or a switch failure and a bunch of things disconnect, dynamic quorum is not going to be able to save you from that situation. In order for dynamic quorum to readjust the number of votes, it has to be able to first maintain quorum using the original rules of quorum that we've all known for many years. So it always has to have quorum majority at the time of shutdown or failure in order to continue. If it cannot recalculate and regain quorum, then it's all going to come down. So it's only, again, for just the individual failures, the single failures. So here's just a real quick example to just illustrate how dynamic quorum could work. I've got 2 data centers over here, my primary data center, which has 3 DAG members, and my witness server represented by that folder, and then 3 DAG members over here in my secondary data center. So what do the rules of quorum tell us? We lose the WAN. What happens in my second data center? Anybody know? That's right. These 3 servers shut down because they are now in the minority and therefore they've lost quorum and they terminate. So now dynamic quorum is left with 4. Before we actually started, the dynamic quorum vote count is 7, as you can see. So 1, 2, 3, 4, 5, 6, and 7. The number of nodes plus that extra vote we get from the witness. So we lose the WAN, therefore we lose 3 simultaneous failures, but we still have a majority over here. So even though we've lost 3 at the same time, we can still maintain quorum over in the primary data center because we still have a majority. And because we're able to regain quorum and we have a majority, dynamic quorum now calculates that the number of votes needed is now 4, down from 7. So if we lose another server and we still have the majority here, we can recalculate. Dynamic quorum is now 3. We lose another server, and boom, that last server that's standing locks the witness server, and now dynamic quorum is 2. 1 for that server and 1 for the witness server. So that's basically how dynamic quorum can work for you in these scenarios. But again, this is going to presuppose that that single server that's now standing on its own can handle all of the active databases from all of those 5 other servers that have now failed. So to look at the voting status of a DAG member, whether you manually take it away or whether it's dynamically taken away, you can simply use the get cluster node commandlet. So if it has a value of 0 for dynamic weight, that means it does not have a vote. If it has a value of 1 for dynamic weight, that means it does have a vote. And the vote assignment can also be verified using the validate cluster quorum test. But that involves going into the cluster tools and using their tools. I find it much easier just to run this one commandlet and find that information out there. Now, the other thing to consider is when you start getting down, let me back up here, when you start getting down to just a couple nodes left and dynamic quorum is doing its thing, when you get down to a situation where you're down to, and let's pretend it's the witness server that failed and we've got 2 exchange servers, one of those exchange servers will have a value of 1 for dynamic weight, the other will have a value of 0. You have no control over who's going to get the 1 and who's going to get the 0. The cluster chooses that randomly on its own. So what that means is you'll want to go and use the commandlet because before you shut down a machine, in this case, you would only want to shut down the machine whose vote is 0. Because if you shut down a machine who had the 1 vote, then that last standing machine now has a vote of 0, and it doesn't have any votes at all, and so it will come down and not be a last man standing. So keep that in mind as well. Dynamic quorum, as interesting as it is from that resilience standpoint, it doesn't change the quorum requirements for DAGs. It doesn't really affect DAGs from a quorum or membership or from a sizing or any other perspective whatsoever. It does work with DAGs, but Exchange has no idea that it's there. It just assumes it's getting information from the cluster as to whether or not it has quorum or not. It doesn't know that votes are being taken away or anything like that. We do all of our testing internally with dynamic quorum enabled, and all of Office 365 has dynamic quorum enabled. So we're very confident that dynamic quorum just works fine for DAGs, doesn't have any ill side effects, and it may give you protection from some scenarios that you didn't have protection from before. So our guidance is pretty simple. The cluster team is very straightforward about this. Keep it enabled. It's going to provide you with availability that's greater than Windows 2008 because it gives you availability for failure scenarios that you didn't have in previous versions. Our guidance is to also leave it enabled for the majority of DAG deployments. We haven't really come up with any reasonable deployment model or business requirement that would warrant disabling dynamic quorum. So we say just keep it enabled, but don't think about it when you're designing your HA plans, when you're designing around failure domains and meeting your business requirements from a resiliency standpoint. Don't bank on dynamic quorum saving you in all these situations where you might not have been able to maintain quorum in previous cases. So just forget that it's there. Maybe one day it'll give you greater availability. It might surprise you, but don't plan on it or even really think about it as some sort of feature that you can leverage for any benefits. All right, let's talk about DAG member maintenance. So DAG member maintenance has changed considerably. We had somewhat basic guidance in Exchange 2010, and we were able to have basic guidance because we included these built-in scripts, the start DAG server maintenance script and the stop DAG server maintenance script. So basically what you would do is you would run the start DAG maintenance server script that would do a whole bunch of work, pause the cluster node, move the databases over, block it for activation, and basically do everything to quiesce all user activity on that system. And then you could go ahead and do your updates. Maybe it was hardware repair, maybe it was software, Exchange update, whatever. When you were done with that, you would reboot, and then you would run the stop DAG server maintenance script, and that would basically undo all of the locks and things that put it into maintenance mode in the first place. It would take it out of maintenance mode and put it back into production for you. It is a very simple and straightforward process. But now, it's a little bit different. It's complicated for a couple reasons. First, again, all mailbox servers are by definition multi-role, so they're all running hub, and CAS along with mailbox. And second, again, we've introduced that new technology called managed availability that is basically watching everything that's important on the system that needs to be watched, and where appropriate, taking automatic corrective action to go ahead and solve that problem. So going into maintenance mode isn't just about quiescing the DAG and the user activity, it's also about telling managed availability that you're about to do maintenance on this system and don't come in behind me and restart services or recycle application pools or reboot the server as I'm trying to install an update on it. And that's very critical for you to do that. So I'll just walk you through the process. Of course, it is documented on TechNet, but I wanted to point out a couple things because I'm sure some of these commandlets are going to be brand new to those of you, even if you're already using Exchange 2013. So the primary commandlets that you'll use to manipulate managed availability, one of them is called set server component state. And managed availability is broken down into groups of components. So as an example, one of the components that you can see here is called Hub Transport. So Hub Transport, that managed availability component, basically translates into all of the transport services and activity that could be running on that server at any given time. You can see in the second line, there's another component, the call router. Again, that translates to the in this case, the specific call router component that's going to be running on a client access server. So if you have CAS and mailbox installed on the same box, you'll also be running that second line. So what you do is you take these components and you put them into a specific state. Now, in the case of Hub Transport and we put them into a state called draining. And draining from the transport perspective means start draining the queues. Go ahead and deliver all the messages, but don't accept any new messages into the queue. Eventually, that queue will get empty as all the messages get delivered. Similarly, with when we're in a draining state, we're basically saying, go ahead and continue any calls that are running, but don't allow any new calls to be initiated. And eventually, all calls will go offline, and will be quiesced automatically. Then, when you put something into maintenance, there's this requester that you put in there. And the requester could be a number of things. Typically, when the administrator is doing maintenance, though, we want them to tag the requester as maintenance. Some other requesters that you might see, for instance, one of them is setup. So when you're running an update, so you're installing CU2 on top of CU1, for example, setup will automatically put the server into maintenance mode, and in that case, the requester will be tagged as setup so that managed availability won't start doing things while setup is doing its thing. There's also a new commandlet that we introduced. Whoops, sorry. I hit the wrong button there. There's also a new commandlet that we introduced called redirect message as well. This will help speed up the draining of your transport queues because basically what it does is as some messages are being delivered, you can use redirect message to take messages from the server that you specify and redirect them to another transport server and basically offload them in bulk over to that other transport server, and then that other transport server is responsible for delivering them. That drains the queues much faster and allows you to actually get to doing your maintenance operation much faster. Now, you do need to suspend the cluster node on your own, and you also need to block and move the databases on your own as well. That is something that we had as part of the scripts in Exchange 2010, but we don't have the new maintenance scripts. We do have the old maintenance scripts that we've still shipped in the box, but those are actually deprecated, so you should not be using those. So when you see the start DAG and stop DAG maintenance scripts, yes, we're still shipping them, but don't use them. Use this set of commands as well. So that means you do have to manually pause the cluster node, and you do have to manually block and move the databases yourself, unfortunately. But of course, these are all the steps that you need. You can certainly put this into your own script as well. And then the last thing that you do is this set server component state, and in this case, the component is server-wide offline. And this is a special managed availability component that is basically a catch-all bucket for all managed availability components on this server. So when we're doing a server-wide offline and we're setting the state to inactive, we're basically telling managed availability that shut off all your responders, the responders being the functions that perform the automatic recovery action. So managed availability will still collect data and it will still evaluate things, but once you have the server-wide offline, it will no longer take that corrective action. So it won't interrupt any of the maintenance tasks that you're doing. After you put a server into maintenance mode, I do like taking the extra step of verifying that it's in truly what I would call a maintenance mode. Now, maintenance mode is not like a real thing where you'll see server X is in maintenance mode. It's just what we call it when the server's being prepared, for maintenance. So to verify that, I always do the get server component state, and I make sure that the server-wide offline is in an active state. I always like to do get mailbox server and pass that and pipe out what database copies are on it to make sure there are only passive copies on that server. And I like to use get cluster node to verify that that node is paused so that it can still participate in voting but does not become the primary active manager. And then I like to use get queue to make sure that the queue is fully drained before I go ahead and bounce the server and start doing work on it as well. Once I'm done with my maintenance, then I take it out of maintenance mode and I put it back into production mode. And the undoing of that is very, very similar to going into maintenance mode. So it's just going to be basically the opposite of what you're doing. You're setting the server-wide offline component, for example, from an inactive to an active state. So you're re-engaging managed availability's ability to do corrective action. You're starting up the call router. You're resuming the node. You're unblocking the databases. You're unrestricting their ability to come over and allowing them to be mounted. And then you're enabling your transport queues at the end of that. And just as before, you can go ahead and use these same commands to verify that you're now back into production mode as you would expect. All right. So that is actually all I wanted to talk about today. I intentionally wanted to leave at least 15 minutes for questions because I wanted you to feel free to ask questions, not just about what we talked about, but also anything that may have been in the prior sessions or really anything in general related to Exchange 2013, HA, Site Resilience, and DR. So with that, if we could maybe bring the lights up just a little bit, and I'd love to start a little bit of Q&A. Let's start over here. Yes, sir. So what state? I missed that when I was grabbing water. Sorry.
Found it in Exchange 2010, the content indexing for
Yes. Yes, so the question is, if you have a MAPI and a replication network, content indexing in Exchange 2010 is what you're asking about, will only go over the MAPI network, and that is still the case in Exchange 2013. One change that we've made, though, around networks, we've actually made several changes, but one change in particular is we're now starting to promote a single NIC deployment in your DAG members, and that would be 1 gigabit or higher, preferably 10 gigabit if you're in a large environment. And that way, you don't have a separate MAPI and replication network. You just have the one network interface, and that keeps things a little bit less complex and a little bit more economical for you as well. Yes, sir?
You didn't put something in the control panel to do the maintenance, Mike? Like it looks like you could have put something in and just, whatever servers you want to do the maintenance on.
Yes. Could we have automated this? Is that your question? Yeah, we could have, and maybe eventually we will. I don't mind saying that. Part of it is this was not the changes that we made architecturally and the kinds of things that are now running on the mailbox server made this a not easily understood process initially. So it took us a few attempts at making sure we had all the right things stopped in just the right way so that we could do maintenance without affecting really anything. So it did take us a while to derive this. It is a fairly simple process, though, as you saw. It's just really just a few lines, and it is something that any admin can literally copy right out of the TechNet article and paste it into PowerShell ISE and make their own script out of it. Eventually, maybe we will one day, but even in the service as we do it ourselves, we take those are the exact steps that we do, and we just put them into our own workflow script. So it's a pretty lightweight and easy thing to do, and given all the other work that we wanted to accomplish at each milestone that we released, this was not really a priority, turning it into a script. Yes, sir.
In Exchange 2010, if you lost your primary data centers, you want to turn your internal data center, the disaster recovery, into your primary one, so your OLO and your active and all that sort of stuff. Obviously, you need to change the internal and external URLs. Is there similar stuff that needs required?
So you don't necessarily change the internal and external URLs. What you really do is you forklift over the namespace by changing DNS. It actually does work. We tested that. We used that extensively in Office 365 when we were running Exchange 2010. But more to your question, there are significant differences in Exchange 2013 where now you do have the ability to get automatic failover and the ability to use a single namespace as well. And a lot of that is covered in the previous HA one, so I would strongly recommend viewing that recording because it lays out all the different site resilience changes that we made. The one thing I typically point out about those changes are the direct reason we have these new capabilities in 2013. So you cannot take the 2013 capabilities and try to do them in 2010. They don't work because 2010's architecture is very different, and we simply don't have the ability to give you the automatic failover in a reasoned and predictable way with 2010. We do now in 2013, and that's something that we hope customers who have the ability to leverage that configuration, we strongly hope that they do that.
With just another, if you had your outage demo and you lost your secondary site, what happened if you lost the primary site?
So, right. So in the configuration I have, so let me go back to it so everyone can understand what we're talking about. So yes, in the configuration I showed you with dynamic quorum, this initial loss, we were simulating the WAN loss, and here we lost our secondary data center because the secondary does not have the majority of voters. So the question is, what would happen if the X were reversed and we lost the primary data center instead? Well, in this configuration, because the majority of votes is located in the primary data center, these servers would have still gone down, and I would have had to do basically the equivalent of a data center switchover to manually bring them back up. But 2013 allows me now a configuration option where that witness server could be in a third location. So if the primary data center does go down and the witness server location is isolated from that failure and still has network connectivity to this side, then this side will maintain core and stay up and running.
That's how I've actually got out of Exchange 2010.
We strongly recommend that you do not configure Exchange 2010 that way. It doesn't matter the load. We strongly recommend against that. That is not a true high availability solution in Exchange 2010 because it's unpredictable in nature. There's a blog post that I wrote a couple years ago called Exchange High Availability Misconceptions. Read that. It lays out all the different reasons that you don't want to go down that route in 2010. And that, in fact, your inability to do that in 2010 is one of the reasons that we did a bunch of work to make this achievable in 2013.
So I followed that recommendation initially, and we did lose our primary data center and had to do the data center file.
Sure. You do that at your own peril. Yes, sir.
In 2010, you had your alternate witness server.
Yes.
Really made any reference to that? Is that still used, I guess?
Great question. Yes. So the question is, in 2010, you had this alternate witness server. Is it still used? So we talked about what the witness server is. The alternate witness server is simply the name for a witness server that you start using when you're doing a data center switchover and you begin using what we called back then an alternate data center, or what we sometimes call now a secondary data center, a DR data center, a standby data center. The other thing, this thing over here. So the alternate witness server, it's not a required property. Only the witness server itself and witness directory are required properties. But if you're in a site resilience configuration, you can use set database availability group to configure an alternate witness server ahead of time so that when you are doing a data center switchover, that the DAG already knows what witness server to start using as part of that. The assumption there being your witness server is part of the dead data center, so you can't use that anymore. Now, you don't have to set it up ahead of time, and typically I recommend that most customers don't, because when you run the restore DAG commandlet, which is the commandlet that you use to recover service in the down data center, that has witness server and witness directory parameters that you can pass a witness server to it at that time. And it's at that point that we'll start using the alternate witness server. It is always a manual switchover process. The alternate witness server does not provide redundancy for the witness server. We don't dynamically switch witness servers. We don't fail over witness servers. It's there for you to manually configure a second witness server during a data center switchover that can be distinguished from the one that might be considered, in that case, the primary witness server. All right, who's next? Yes, sir.
You touched on it there, but with the cross-site failover for a DAG, with the change from 10, you had the allow cross-site RPC connectivity
Yes.
and the enable preferred site enforcement.
Yes.
We had some issues with that for a couple of clients, and that's all gone.
Those issues are gone and gone. Here's why. There is no more RPC client access object anymore. So when we talk about the CAS array in Exchange 2013, it's not the RPC CAS array. The CAS array in 2013 is just a made-up name to refer to a group of CAS that are in the same site behind the same load balancer. It's not a thing that you need to configure anymore. It's not a property that you manipulate. And in fact, you may see vestiges of the property on the mailbox database object, but they're not used anymore. They're completely ignored. I can't remember if we took them out or not. I know they were still in there at RTM. I think we tried to get them out in CU1 or CU2, but I haven't looked lately to verify that. But we don't use those anymore. And more importantly, architecturally, we have decoupled CAS and mailbox from each other, both from a namespace and DAG standpoint, and from an AD site connectedness standpoint, and from a recovery standpoint as well. So that's why we can fail over independently at the DAG and really not have to do anything with the namespace. Or vice versa, maybe your load balancer fails and you need to have your clients go over to the other data center for CAS connectivity. Your DAG can be completely untouched in that whole failure experience, and those CAS on the other site will simply just proxy to the mailboxes that still survive and are unaffected by that failure. So you don't have to worry about those kinds of operations anymore because they simply don't exist. Yes, sir?
In terms of the auto failover to work, you need to put when you're serving the server side. What if I have odd number of customer members?
If you have an odd number, well, now you're in an unusual state. In that case, you would hopefully, I don't know what your layout is going to be, but in your case, you may decide to take one of those nodes, and instead of the witness server being in the third site, a node would be in the third site. Now, if you're going to have active databases on that node, then you'll have other network requirements above and beyond the witness server network requirements, so keep that in mind. But there is also this concept of a voting-only node as well. So if you didn't want to place any load on that, you could simply just deploy a mailbox server in that other site and have it act as the vote. If you are going to do that, though, you're probably wasting money on the Exchange license for that server because it's not doing any Exchange work. You should probably not buy Exchange for that and just use a regular file server or some server that you have in that other site. But if you do place load on it because it's part of your topology and that's the server that you need to support the number of databases and database copies that you need, then you're going to have some additional network requirements and probably some added complexity as well. But that having said, if you execute and operate that successfully, you would still achieve the automatic failover.
And, can you describe a bit of the auto discover process during the DR scenario?
Sure. So it depends on the scenario largely, but all of our large-scale disaster type of operations typically involve moving a namespace over or continuing to use the same single namespace with multiple A records in DNS to give you multiple IP addresses behind that namespace in order to operate successfully. So basically, once DNS is updated, then AutoDiscover finds the new places because the client's got the new address, so they get the server name back, they resolve it, and now it's resolving over to the new place instead. So it's a very smooth and seamless operation. All clients, when you're in an automatic failover situation, we've tested ActiveSync, OA, POP, IMAP, and of course Outlook as well. All clients exhibit the same general behavior in that, which is automatic reconnection. So it's a very, very quick and easy process for them. Yep. Let's see. Yes, sir.
So if you were saying that when you're doing admin actions, so if you're dismounting a database, et cetera, that Active Manager won't come in and go, hey, wait a minute, and remount.
Correct.
So in that case, how do you test? How do you test a failure?
There's a lot of different ways you can test failure. So the question is, if I'm gracefully terminating something, how can I test a failure scenario? Well, gracefully terminating something isn't a failure scenario, so that wouldn't even be a viable test to begin with. So you would want to do something like terminate the process that owns the database. So we have a worker process model with the store now, so that each database has its own separate process attached to it, its own separate database cache, its own separate RPC endpoint, and so forth. So you could find the worker process. You can use Get Mailbox Database to find the PID of the task and find that process and then kill it, and that will terminate that database. So that's one way to do it. Other ways to do it are to go into Disk Manager and kill a disk that has a database on it, or pull network cables out, or power off servers, those kinds of things. Any kind of unexpected interruption in activity should be a viable test for failover in a DAG.
And one more. When you're running through, when you're putting something into maintenance mode, you're running through each of those steps.
Yes.
You're saying, so at the start you wait for all your queues to empty. Can you just run all those steps?
Yes, you don't wait for the queue to empty before you go to the next step. Sorry if I wasn't clear about that. You can run those steps in a script. It'll just do all those things, and once you set the component state into draining, then it's going to begin the process of no longer accepting messages. So the queue's still going to keep working. It's still getting rid of messages that it needs to process. It's just not going to take any new ones in. And then to accelerate the process, now we've got redirect message as well. So as the queue is doing some of its thing, the rest of the message can go over to another server for delivery.
And I also noticed there was some typos in that. So,
In what slide?
where you have the commands, the requester was ER and OR.
Ah, good catch, yes. It should be E. Ah, thank you. How's this for agility? That's so funny. Good eye. And I'll find out later it should be O. Thank you for that. I'll make sure we get the corrected one uploaded. All right, yes, sir.
Sorry, I missed the other session you were talking about the information store needing to be restarted.
Yes.
Does that drop all the databases, or is it all isolated?
So when we talk about the information store itself, so we use a worker process model. So there is a managed code service called Microsoft.exchange.store.service.exe. That would be the equivalent to the legacy store.exe, which is now gone. And then each of the databases has Microsoft.exchange.store.worker.exe. So you can tell the difference between the two. Now, the store service is really nothing more than a thin, lightweight controller service whose whole lot in life is to control the life cycle of the worker processes. So if a database is mounted, the store instantiates a new worker process. If a database is dismounted, the store terminates that process. So if you stop and start the store, all worker processes go down and it comes back up. So yes, there is an interruption for database connection. Our feeling, though, is that when you are adding databases or removing them or adding or removing database copies, you're probably doing that through some maintenance window anyway, which means you've moved all of the active copies over to another server. So it's not a big deal for passive databases to temporarily dismount and then be remounted again during that operation. But it is something that you have to do, otherwise the database cache will not get correctly calculated. What's that? Yes, well, if you have a single server, I mean, there's no way to offload it. Yeah, you've got to do the maintenance. There's going to be an interruption and outage. A single server deployment can never give you availability during a maintenance operation. There's just no way to have service go somewhere else. You need at least 2 servers, 2 Exchange servers, and 3 physical servers to do Exchange HA.
Yeah, but in the sense that before I could do that operation without needing to restart.
Yes. Yes.
It's a bit annoying.
Yes, it shouldn't be too annoying. We don't typically contemplate single server deployments when we think about administrative scenarios, to be quite honest with you. We worked incredibly hard over many versions of Exchange to make the DAG and high availability within the reach of all customers. So even the smallest customers, if for some reason they can't go to the cloud and have all that done for them automatically, in fact, FYI, if you want awesome Exchange HA and site resilience with 0 admin burden, Office 365. But if they're on premises and they need HA, then they need at least 2 Exchange servers. So we don't typically think too hard about the single server deployments.
I was just going to say that if you probably run SPS or something anyway, you can pretty much fairly easily take an outage window, I can imagine. I mean, you're not going to be disrupting that many people if you're only running SPS.
Yeah, we don't contemplate SBS deployments as well. Obviously, they use the same version of Exchange that we ship, but we don't think about those deployments when we're talking about Exchange HA. Yes, sir.
With the new redirected message commandlet, does that pick up, sort of a two-phase question, does that actually move the queue files over SMB, for example, or does it reroute?
It reroutes the messages. Yeah, and you'll see that in the log files too. If you look at the transport logs, you'll see those messages getting rerouted. So anytime we have the queue in that state, it will automatically go ahead and redirect them that way.
All right, secondly, probably something I should go and look at myself, but can you redirect a particular queue, or does it just do the entire server?
So that's a good question. I haven't tried individual queues or individual messages because we were looking at this from the context of what's the fastest we can get the server ready to do maintenance. And from our perspective, we want to move all the messages. We don't want to just leave some of them there. We want them all off as soon as possible. So I'd have to go back and test. Or if you want to test and let me know what you find out, that's cool too. If you want to do the work and let me take the credit for it, I will. Yes, sir.
I just wanted to know what your thoughts were on using ARR for load balancing Exchange 2013 with IIS.
It really depends on what your load balancing needs are. I mean, every customer is going to have different load balancing needs. I don't know that ARR is going to provide you with, first of all, it's not going to provide you with really the kind of robust load balancing that you would expect with an enterprise level Exchange deployment. You really do need something, some level of sophistication to it in terms of service awareness, intelligence, and so forth. So I would look at something like that as, kind of a poor man's solution, like Windows Network load balancing would be another poor man's solution along that case. It's something that, we have published some guidance about using it for as basically a proxy solution, not really a load balancing solution, but it could be adapted for that as well. But it's not something that I would go to a customer and promote in any sense. All right, I think we've got about a minute and a half left, so maybe time for one more question. Let's go way in the back then.
Is there anything they looked at for assisting patching DAG service?
So the question is there anything being looked at for patching with patching DAG members? Not really, and there's two reasons for that. The first is we don't really like automatic updating of DAG members because, as you saw, there's quite a few things that you want to do before you just start applying updates onto the system. And so since you have to do manual activities to just get to the point where you can install the updates, our feeling is you might as well continue to just manually do the updates. The other reason that there may not be any work in that area is because of the way that we patch in the service. So a lot of the work that we're doing now to benefit on-premises administrators stems from the benefits we get from things we're doing ourselves in the service. But the way that we patch our I should say update, because we don't even patch our servers, the way we do our updates in the cloud is we actually take the server completely down to bare metal, and we do a complete fresh reinstall with the patches integrated to that deployment process. So we don't do any incremental updates or MSP patches or anything like that. It's always a brand new fresh install with the latest bits integrated into that install process. And so for that reason, we don't really we don't have any reason to develop that kind of code for our own purposes in the cloud. So it would be kind of a bit of a challenge to get resources to develop it just as an on-premises solution only. So, all right, I'm a few seconds over, so that's all we have time for. I hope to see you at Tips and Tricks as well, because we'll talk about some other interesting things. Thanks for coming.